Okay, Cloud Gurus, the high level. And there's two things I want to start out with: the basic premise and then the lingo. First up, the basic premise of volumes in Kubernetes is to abstract storage or data from pods. So, without volumes, your data lives and dies with the pod it's associated with. You spin up a pod, write some important data to it, the pod crashes or gets scaled out or whatever, and it's goodbye data. Which isn't always ideal, no, especially for the persistent bits of your apps. With volumes, though, we get to create and manage volumes as volumes, so they exist on the cluster in their own right. Then, if a pod wants to use one, it needs to lay a claim to it and mount it. Then if the pod dies or whatever, the volume still exists. It is absolutely not tied to the life cycle of the pod. And there's more, yeah? I mean, you can share volumes between multiple pods. Restrictions do apply, okay? But it's possible. And I think that's the premise, yeah? Volumes decouple storage from pods. And it's a good thing. Magic. Well, the second thing I want to say is that the lingo is volumes. So storage is like any other tech. It's got way too many acronyms and terms that, I don't know, basically mean the same thing. So we've got LUNs, devices, shares, mounts, bind mounts, spaces, whatever, right? And I know some people care passionately about the nuances and what have you, and that's alright. But at the kind of high level a Kubernetes admin sits at, they all mean the same thing: some place to persistently store your data. So, if it's backed by a SCSI LUN or an SMB share, we're not bothered, we're calling it a volume. Now then, despite being boring to most people, storage actually is vital. In fact, so vital that enterprises spend disgusting amounts of money on things like enterprise-class storage arrays. So with this in mind, storage needs to be a first-class citizen in Kubernetes. And now it is. Well, at least file and block is, which is a good thing, right? Because for the longest time, storage was, I don't know, second, third, maybe even fourth class. Now, what I mean by first-class citizen in Kubernetes is that we have got strong standards-based support for persistent storage like file and block. And you can bring your favorite enterprise array. Plus, Kubernetes has this rich set of APIs that let us consume and manage it. Okay, so Kubernetes loves storage, but if you're a developer or whatever, what might your storage requirements look like? Well, it's things like, do you need fast storage? And you know what? The answer is not always yes. There's a cost to consider, yeah? Fast isn't usually cheap. There is, does it need replicating? Should it be read-only? If it needs to be writable, do you need more than one pod to be able to write to it? How resilient does it need to be? Even things like, will it store sensitive data, so should it be deleted when you're done with it? These are some of the things you need to consider. Unfortunately, Kubernetes has got something to offer on most accounts. But when it comes to most of this stuff like speed and resilience, yeah, Kubernetes leaves all of that up to the storage provider, which is where you bring in your enterprise array, or if you're in the cloud, your EBS or S3 and the likes, yeah? It is those back-end systems that provide all of the different tiers and the different features. Kubernetes just provides an interface for pods to consume it, which I know, right, is a bit high level, I get it, but the detail is coming. Before we do that though, I want to quickly run over the main Kubernetes resources for working with storage, because I really think a big picture view of what's coming is going to be massively helpful. So, you've got your storage system, Enterprise Array Cloud Service Choose Your Poison. That plugs into Kubernetes, and Kubernetes gives you a nice way to consume it through your app. So, this plugin model is based on something we call the Container Storage Interface, or CSI for short. Details to come again, but it's a really slick way for storage providers to write plugins that expose features to Kubernetes. Then on this side, the CSI leverages the Kubernetes API objects for easy consumption. Now, I get it, I'm probably being a bit oversimple with things here. But we've got the storage systems here and all of their features. CSI in the middle, making it easy for them to interface with Kubernetes. Then on this side, we've got the Kubernetes persistent volume subsystem. So I think at the highest level, it's implementation details on this side, and then consumption on this side, with the plugin abstracting away all of the messy detail on the left. Now then, we're going to be spending most of our time learning this stuff on this side, right? Which at a high level is three main things: persistent volumes, persistent volume claims, and storage classes. Think of persistent volumes, which we call PVs, as the storage resource. So maybe a 20 gig volume based on fast SSD. And then the persistent volume claim, which we call the PVC, is the application's ticket to be able to use it. So, I don't know, your cluster might have a bunch of different PVs. And for your application to use one, it needs a PVC, like a voucher or a ticket to use, yeah? And like I keep saying, we'll get to the detail in a second, but storage classes, that's just a way to implement all of this in a more dynamic and scalable way. Alright, look, we're done. That's the super high level. Time to start digging. And first on the cards is the CSI plugin layer.